All right, these are extra examples to go with solving trigonometric equations. So let's dive right in. We're going to solve over the intervals 0 to 2 pi, but we're going to write our answers in set notation this time. So we want to start by getting all the trig functions on one side. They are, but this isn't helpful unless it's equal to 0, so I'll subtract that 1 over. And now I can factor. I factor it into 2 sine of x and sine of x. I know I have to use a 1 and a 1, plus there, minus there. Set each factor equal to 0. And then I solve from there. I'll add this 1 and divide by 2. And this side I'll subtract 1, and that's it. So between 0 and 2 pi, where does the sine of x equal 1/2? To write it in set notation, it really just means I'm going to write them in swirly brackets. X equals, where's the sine 1/2? That's pi over 6, or 5 pi over 6. Where's sine -1? 3 pi over 2. There's my answer. All right, this next one, very, very similar. We're going to start by just factoring, though, because it's already equal to 0. So I have 2 sine of x and just sine of x. To use a 4 to make a 7, I need 8 and 1, so minus 4, or plus 4 minus 1. There we go. Set each factor equal to 0. I will add the 1 for the first one, and then I will divide by 2. Second one, I will subtract 4, and sine of x is alone. So now I say, all right, on the interval 0 to 2 pi, where is the sine 1/2? Pi over 6, and 5 pi over 6. Where's the sine -4? Nowhere. That actually gives us no solution, so I can ignore it. And here's my answer. All right, for cosine of x minus 3, sorry, cosine squared of x minus 3 equals 0. Let's get that cosine alone. Add the 3. Divide by 4. And then square root both sides. So cosine of x equals positive or negative square root of 3 over 2. So we're only working on 0 to 2 pi. So where's cosine? Positive or negative square root of 3 over 2. That's pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right, this problem, we need it in just one trig function. Secant squared can actually become 1 plus tangent squared. Get it equal to 0, so I subtract 1. And I get tangent squared of x plus tangent of x equals 0. Remember to factor out the GCF, leaving me tangent of x plus 1, and then set both factors equal to 0. So tangent of x equals 0, and tangent of x plus 1 equals 0. This side we have to subtract the 1. Tangent of x equals -1. So my answer is between 0 and 2 pi. Where is the tangent 0? Well, tangent's always y over x, so that's 0 and pi. Where's tangent -1? That's 3 pi over 4 and 7 pi over 4. There's our answer. All right, now we're going to solve over the interval 0 to 2 pi and also over the set of all real numbers. So let's look at that. Get my tangents on one side. I get 3 tangent of x equals square root of 3. Divide by 3. And the tangent of x equals square root 3 over 3. Let's start with the interval 0 to 2 pi. Between 0 and 2 pi, where is x, or where's the tangent of x square root 3 over 3? That's at pi over 6 and 7 pi over 6. Remember that the period of tangent is n pi instead of 2 pi. So we can write this as pi over 6 plus n pi. And I don't need a second piece because that already hits 7 pi over 6. There's our answer. All right, same type of thing. Look for a GCF. I'm going to take a cosine of x out of both pieces. And then set both factors equal to 0. Second one, we have to add the 1 and divide by 2. And now I can get my answers. Let's start with 0 to 2 pi. Where's cosine 0? That's at pi over 2 and 3 pi over 2. Where's sine 1/2? That's pi over 6 and 5 pi over 6. So now we want all solutions. I noticed that these two are actually just a pi apart. So I'm going to go pi over 2 plus n pi. I can't do that with the pi over 6 and 5 pi over 6 because it would be 4 pi over 6, which would make 10 pi over 6, which isn't an answer. So I have to keep those two separate. Pi over 6 plus 2n pi and 5 pi over 6 plus 2n pi. All right, similar type of problem. Get it equal to 0. Subtract that tangent over. I get the tangent of x times sine squared of x minus tangent of x equals 0. Factor out my GCF, which is a tangent of x. And then set both pieces equal to 0. A little work on the right-hand one here. Square root both sides. Sine of x equals plus or minus 1. All right. First question is, where's tangent 0? Tangent 0 at 0 and pi. Where's sine 1 or negative 1? Well, that's pi over 2 and 3 pi over 2. But here we run into a problem. Tangent's not defined at pi over 2 or 3 pi over 2. Here are our extraneous solutions. So really our answer is 0 and pi. So our only possible answers are x equals n pi. So we did all that work and then had to get rid of most of our answer. All right, this one's looking crazy for us. We have to do some rewriting first. I know that I can split this first fraction apart into cosine over sine times cosine squared. And cosine over sine is cotangent. Now I can treat it like the last ones. I'll subtract cotangent over. I'll factor the cotangent of x out. And I'll set both factors equal to 0. I'll add 1. And then I'll square root, giving me the cosine of x equals positive or negative 1. All right, my answer is, where does cotangent equal 0? That's at pi over 2 and 3 pi over 2. Where's cosine equals plus or minus 1? 0 and pi. But always think about, does any part of my answer make any part of the problem undefined? Well, the cotangent of pi is undefined, and the cotangent of 0 is undefined. So those are extraneous solutions. So my answer is actually just pi over 2 and 3 pi over 2. Which means my general solution can be pi over 2 plus n pi. All right, we are going to write general solution and specific solution, but now we have sine of 2x. Start off the same way, get that sign alone. Divide by 2. All right, now I would go for the general solution first. So where's sine square root 3 over 2? Pi over 3 plus 2n pi and 2 pi over 3 plus 2n pi. I divide both sides by 2. I get pi over 6 plus n pi, and same thing here, x equals pi over 3 plus n pi. Now let's use that to figure out all of our solutions between 0 and 2 pi. We start with pi over 6. All right. Then we add n pi, which makes 7 pi over 6, which is still between 0 and 2 pi. If I add n pi again, I get 13 pi over 6, which is more than 2 pi. All right, then I have pi over 3. Add n pi. I get 4 pi over 3, which is still between 0 and 2 pi. Add pi again, and I get 7 pi over 3, which is too big. So I had more solutions because of that multiple angle inside my trig function. All right, let's try that same idea again. I'm going to start by getting the cosine alone, so I subtract 1. Cosine of 3x equals -1. Where is cosine equal to -1? That's at pi. Plus 2n pi, because it's cosine. Then we divide by 3. X equals pi over 3 plus 2n pi over 3. There's my general answer. My specific answers are going to be pi over 3 plus 2 pi over 3, which makes pi, plus 2 pi over 3, which makes 5 pi over 3, plus 2 pi over 3 makes 7 pi over 3, which is too big. All right, same type of deal. I start by getting my sine alone. I add 1. All right, where does sine equal 1? Well, that is at pi over 2 plus 2n pi. This time I'm going to multiply both sides by 2. X equals pi plus 4n pi. So my specific solutions between 0 and 2 pi, I get pi. If I add 4 pi, though, I'm at 5 pi, which is already too big, so I've only got one answer now. All right, same type of deal with the cosine. I'm going to start by subtracting the 1. I'm going to divide by 2. And then I'm going to say, all right, where does cosine equal -1/2? 2 pi over 3 plus 2n pi. Oops, wow, I'm just writing all sorts of things wrong. Sorry. X over 2 equals 2 pi over 3 plus 2n pi. There we go. And x over 2 equals 4 pi over 3 plus 2n pi. So I multiply both sides by 2. I get x equals 4 pi over 3 plus 4n pi. And same thing over here. I get x equals 8 pi over 3 plus 4n pi. Now for my answers between 0 and 2 pi. 4 pi over 3. But if I add 4 pi, it's way too big. 8 pi over 3 is too big. But if I tried to subtract 4 pi, it would be less than 0, So I've only actually got one answer that falls on that interval. All right, now we're getting somewhere. We've got a shift in there. So we start off the same way though. Sine equals negative square root 2 over 2. Well, that is at 5 pi over 4 plus 2n pi and 7 pi over 4 plus 2n pi. This time we just have x minus pi over 3. So instead of multiplying or dividing by something, I'm just going to add pi over 3. Now I do have to do a little work for this because I need a common denominator. So I'm going to make it 12ths. So I have 15 pi over 12 plus 4 pi over 12 plus 2n pi, which makes 19 pi over 12 plus 2n pi. Same thing over here, I'll add pi over 3. X equals, let's turn it into 12ths, so 21 pi plus 4 pi over 12 plus 2n pi. And I get x equals 25 pi over 12 plus 2n pi. Then I need any answers that fall between 0 and 2 pi. Well, 19 pi over 12 works. If I add 2 pi, it's too big. If I subtract 2 pi, it's too small. 25 pi over 12 is actually bigger than 2 pi. So if I subtract 2 pi, I'm actually left with 1 pi over 12. So I have another answer that wasn't actually in my original. All right, 2, cotangent of x minus pi over 4 plus 2. Same thing we just did there. We are going to subtract 2. And then divide by 2. All right, determine where the cotangent equals -1. X minus pi over 4 should equal 3 pi over 4 plus n pi. And that's all of it because the other one is 7 pi over 4, which is n pi away. So I add pi over 4. Which gives me x equals pi plus n pi, which really I can just shorten to pi, x equals n pi. So between 0 and 2 pi, I have 0 and pi as possible answers. All right, more time to practice.